Hey everyone, first of all, thank you for watching my talk. I am Antonio Malheiros from MercadoLibre, and today I'm going to talk about an authorization service implementation strategy for an internal development platform. But before getting into it, let's recap some important concepts. When a call is made to a service for environments where you need to have the user context, you usually have some access token, cookie, or other session identifier just to identify who is making the request. So whenever we're talking about who, we're talking about authentication. Now, if you need to know if the same user, after being identified, can or cannot perform a certain action, we'll be talking about authorization. For example, if I want to know if this user has permission to make a payment or to transfer money. At the first glance, if we think of a single and isolated implementation of a monolithic service, you can imagine that's something trivial. As you can see in this piece of code, where there is a middle responsible for validating whether the user is authenticated and whether the user has permission to do some action. So it looks like simple, no? Now, if we were to imagine this in an ecosystem like MercadoLibre, where we have more than 10,000 developers, more than 26,000 microservices, and 10,000 plus per day, this solution can bring us some problem. Here, I mentioned the scale of MercadoLibre, but it applies to any scenario where you already have a microservices running on scale, on the platform, and want to have more in-depth control. So let's take a look about the trade-offs of this approach. When you have the amount of microservices and delegate this responsibility to each application, you depend on each application to carry out this implementation and do it correctly at the correct point. Imagine that you validate the authorization, but you validate after some request or after some specific points. You probably don't know each application will implement it or they don't. So you won't have the governance over it and a more accurate control. So it will be a problem for you. Now imagine your company has some forms of session, cookies, access token, APKs, etc. Each application will have to know how to deal with this complexity. In validating the expiration of JWT, for example, in addition to also having to be careful if the applications are not logging the super sensitive data. After all, if it leaks, you can make a call with this data. Speaking about internal development platform, we know that one of the main gains that we have is that developer time is more focused on the problem of his business unit and not knowing how to deal with authentication authorization. So abstracting this complexity from him, you are ultimately giving him more time to focus on other things. And last but not least, in a decentralized strategy, you cannot have an enforcement point. That is, if you want to enforce a policy like every client that is going to make a transfer needs to have a higher level of security, you probably have to go through all the applications to see if they are following this guideline or not. Those trade-offs of this approach that I mentioned, there are other approaches that you can use, like external lib, service, or something like that. However, what we're going to comment on is the strategy of externalizing the responsibility for the application, moving the authentication authorization layers to the edge of the applications. In this approach that we have in the simplified design here, when the client make an interaction with your service, it goes through an edge layer that's responsible for extracting the header or data from the session, going to the responsible service to validate whether either can pass or not. Normally return 401 in case that is not valid. By externalizing this, we eliminated the complexity that each application has to know how to handle the responsibility of authentication, and we gain external visibility and metrics. Any service that has public exposure has to go through this layer. This layer is also in charge of sanitizing the request that is eliminating the valid headers and adding data that will be passed on to internal application. This data is a JWT that cannot be changed by future applications, ensure request traceability and eliminating the risk of token leakage. After authentication is performed, an identity token is created. This identity token is your internal identity. The requests are arrived to the application, which has an ingress and outbound proxy sidecar that looks at the identity and roles to find out if the request should go ahead or if it should be denied. A match is made with a set of rules created by the owner of the application in the policy manager. To increase the availability of the service, the created rules are synchronized with each application, so it's not necessary to make external call from the sidecar. Of course, no solution is a silver bullet, and this one also has some trade-offs. Some points I mentioned early in the solution we managed to solve. So let's see about the trade-offs. So we have a point that we can have enforcement policies, simple and more complex. We leave the applications with less responsibility. That's very good. I didn't comment before, but one gain we have here is that we can change the rule of we don't need to deploy the application, so you have how deploys. We have greater traceability with the identity, and we have improved monitoring information on the percentage of requests that is denied or not, and why they are denied. We can create unit tests for policies and achieve faster development of application, and especially fixes for broken access control. As I said, this approach also had some cons. It is neither simple nor quick to implement. It requires dealing with different types of traffic and requires a major paradigm shift. Depending on the level at which the company is, there is a cost of migrating from the current form to this form that I presented before. So moving to the edge has a cost for your paradigm. We have moved from one paradigm to another, and we have learned a lot from it, and a few things I want to highlight. For many cases, you have to go beyond role validation, merging with attributes, resourcing, and other things. In these cases, it is important to rely on some language or to be able to extend it in some way, such as with Open Policy Agent. If your company is already using a library or something like that in a distributed way, moving to this more centralized form of control is a cultural challenge for developers and the company. This will be challenge. A constant improvement in the authorization response time is necessary. At this time, we have more than 3 million requests per minute with an SLI, the 39s, and our P95 is 13 milliseconds. Having granular metrics at the level of each application and sidecar is challenging because the volume can be very high. You have to think about sampling requests to analyze, and of course, it is important to have strong resilience strategy because it cannot be a single point of failure for all applications. This is a very big risk and a very critical service, so you have to think about it and structure your database and structure all of the service to be very, very resilient. Finally, I would like to reinforce that authorization cannot be a minor issue in a platform environment. Broken access control nowadays is the first in the OWASP vulnerability ranking. Without doubt, having a service within your platform to deal with authorization authentication can bring many benefits in terms of security and scalability. And thinking about how to extend the solution to go beyond rules, more complex validation that are in the context of authorization, and add more security and business value to that layer. I hope you guys enjoyed it. I am looking forward to hearing your feedback and insights on the topic. Let's stay connected. and continue the conversation. Thank you. See you all. Bye bye.